Hi guys, welcome back. So, how are you all? And today we are back with our matrices chapter, and we will be learning operations of matrices in this session. Okay, so in previous sessions we have learned about the what is the matrix, representation of a matrix. Then we have learned about types of matrix, right? Here we'll be in detail learning about operations of matrix. So when you take the word operation, what comes to your mind? Basically it is the addition, subtraction, multiplication of matrices, or there are different kinds of multiplication also. Scalar multiplication is there and normal two matrix multiplication is there, right? So that is what we are going to learn today. So we will be learning the properties and operation that are performed in the matrix. Okay, so can we start the session? Okay, so yeah, now operations of matrix. So generally when it comes to operations of matrix, what all do you know? You know there is addition, subtraction, everything, right? So that is what we are going to learn today. Okay, so yeah, let's quickly get into the video. 1 second. Yes. So now let's see the operations that are performed in the matrix. So let's start with the addition of matrices. Okay. So when addition of matrix, let me write the addition of matrix. So it will be addition of matrices. Addition of matrices. So basically when you're adding any number, you will have two. Basically you have two components, then you'll be adding. Same way here you'll be having two matrices, but in matrix you have a concept called order, right? So I will ask you a question. If your matrix is of different order, can you add it? Or if it is of same order, can you add it? This is the important question which you have to get inside the mind. So now when I talk about it, it is basically I'm having A and B are two matrices. So I'm taking two matrices which is A and B. So here I am adding it. So basically I'm taking my A matrix as Aij, and here my order I'm taking it as M cross N. Okay, and same way B is there, no, B matrix. So B matrix here I'll be taking it as Bij. So inside this, what I'll be there? Inside this, I'll be taking it as M cross N. So basically, when you're adding two matrices, one main criteria which you have to remember is your order. Your order should be same for two matrices. Okay, same way now when we are adding. Okay, when we are adding A plus B, this is basically what, when you add both, you have to add the corresponding elements together. Okay, so I'll be adding corresponding elements together. Okay, so Bij, which is M cross N. So this is 1 less than equal to I less than equal to M. So this is again 1 less than equal to J less than equal to N. Like this only it will be there. You have to add the corresponding values of the matrices. So I will explain you clearly with the I'll be explaining you clearly with the representation of matrices. So let's quickly go to the representation of matrix. So here you are having a matrix, say 2 cross 2 matrix. I'm taking 2 cross 2 matrix. Again, one more matrix you are having. So this is also a 2 cross 2. Okay, 2 cross 2 matrix. So I already told you, in order to to matrix, what you should need, you should have the order same, that is the number of rows and number of columns should be same. Okay, so now let me let me keep this as red circle. Okay. Let me give it a name. Say 1. Okay, 1 you're having, so 1 here, and you're having 2 here. Okay, I'm having I'm just writing it in different color so that you know. So I'm having 3 here, I'm having 4 here. Okay, now let me write in green, which is 5 here, 6 here, and black, which is 7. So now look at the colors. What colors? When you look at the colors, I'm having 1 in the first row and first column. Same way, I'm having 2 in the first row and first column. So basically, you will be adding the corresponding elements. So which is basically 1 plus 2. Okay, I'm adding the corresponding elements. Same way, again you have a 3 here and you have a 4 here, which is the first row and second column you have 3 as the element, and first row and second column you have 4 as the element. So it will be 3 plus 4. Okay, now what is this? 5 and 6. So again in second row and first column you have 5, and you have to add the corresponding element. So which is, what is your second row and second column here? Here you'll be having what? Which number? 6. Okay, so that is what you will be having. Similarly, now you have 7 in second row, second column. Same, you have 7 in second row and second column. Okay, so this will be your matrix addition. So basically it will be 3 plus 7, 3, 7, 11, 14. So this is my 2 cross 2 matrix. Okay. So are you clear with the concept of 2 cross 2 matrix? So this is addition of 2 cross 2. Now let me ask you, you are having a matrix of order 2 cross 3. So if you are having a matrix of order 2 cross 3 and one more matrix of order 3 cross 2, can you add it? No. The answer for this is definitely strictly no. You cannot add a matrix which is of different orders. Hope you are clear. Okay. Now let's go to the subtraction of matrices. So here when I subtract it, basically it will be, so subtraction of matrices. So here basically what will be that I'm taking 2 matrices. Okay, so here I'm taking A and B matrices. So I'm taking A and B are 2 matrices. Okay, so A and B are 2 matrices of what? Of same order. So I'm taking A and B are 2 matrices of same order. So what can you do? So basically this point is very important. You're adding a matrix or you're subtracting a matrix. If my A is nothing but Aij, which is M cross N. B is nothing but Bij, which is M cross N. So when I subtract 2 matrices, basically A minus B. So this will basically be Aij minus Bij of M cross N. So this is my matrix. Okay, you will be subtracting the elements basically. So it will be 1 less than or equal to I less than or equal to M. Again 1 less than or equal to J less than or equal to N. So this will be my order of it. Like generally your I will be varying from 1 to M, your J will be varying from 1 to N. Okay, same way, let me give you an example. You're having a matrix A, say A matrix is nothing but 1, 2, 3, 4, 5, 6. Okay, now this is my A matrix. Same way, my B matrix is nothing but, this is nothing but 3 cross 2. You have 3 rows and 2 columns. Okay, same way here it will be 0, 1, 2, 3, 4 and 5. This is again a 3 cross 2 matrix. So first condition, what will you check? So first condition, you will be checking it as whether you're having same order or not. Okay. So now you will be, when you check if you're having same order, so that condition is satisfied. It is having same order. So now I am subtracting both the matrices. When I subtract both the matrices, I will be subtracting the individual elements. So basically 1 minus 0, the first row and first element. First row and second element. Second row and first element. Second row and second element. Third row and first element. Third row and second element. Okay. Like this only you will be having. Okay. Now what happens? So this will be equal to 1, 1, 1, 1, 1, 1. Your subtracted answer, which is this, is your A minus B. When you subtract a number, basically A from B, you will be having this one. Okay. I hope you are clear. Now, yeah. Yes. Now let's go to the next one. So next one is negative of a matrix. So negative of a matrix. So this is what you will be doing. Now let's see about negative of matrix. So here it will be A will be equal to Aij, which is M cross N. Okay. So for taking a negative of matrix, basically you will be needing one particular matrix. Okay. For taking a negative of matrix, how much will you need? You will be needing one particular matrix. And for that you have to take negative. In the term negative itself, you will be able to understand if you're having a positive term, that will be opposite. Like basically if you have a positive 1, you'll be getting minus 1. If you're having minus 1, you'll be getting positive 1. So that is what you will be getting. Okay. So now, so minus A will be equal to minus Aij into M cross N. So basically each and every element will be the negative of it. Okay. Each and every element. So let me take, that is called negative basically. Let me take an example. So A is equal to, I'm taking 1, 2, 3, 4. If I take negative of A, each and every element will be negative. So basically it will be minus 1, minus 2, minus 3 and comes minus 4. Like this only we will be doing. Okay. For example, if I tell some other terms, will be B. So B will be basically 1, 2, 3, minus 3, minus 4. If you're having this term, what is negative of B? So basically minus B is equal to minus 1, minus 2, 3 and 4. This is what you will be getting. Okay. So are you clear with the negative? Basically this, you should remember this one. If you're having negative, if you're having a matrix, the negative of it will be the answer. Okay. Are you clear? Are you clear? Is it okay? Now let's go to the properties of matrix addition. So what are the properties of matrix addition? So first, as usual, you know, general properties of matrix addition are there. What are the properties? Generally, you will be adding two matrices. If you are adding two matrices or any numbers, you will be generally having commutative property, associative property, identity, many things are there. No? So same way only we will be doing. So addition of matrices. So generally addition of matrices is commutative. What does that mean? So when you are adding two matrices, basically if you are adding A plus B, and here what is A and what is B? Here A is a matrix, B is a matrix, and for adding matrices both the order should be same. Same way here A matrices order is also same and B matrices order is also same. So I'll be writing these two are two matrices of order M cross N. Sorry. So these are two matrices of order M cross N. So A plus B is equal to B plus A. So this is what will be your final answer, which means it is commutative. Hi. Hi Megla. So yeah, நல்லா இருக்கேன். ஆல்ரெடி எனக்கு தெரியுமா உங்களுக்கு சூப்பரா இருக்கேன். So okay, now let's talk about the other one. Okay, now எப்படி வந்து associative property. Now let's see about associative properties. Okay, so basically your associative property to like basically addition of a matrices is associative. So addition of matrices is associative. Okay, so when என்ன தெரியாம இருக்குமா? So you are in 12th standard right now. Are you studying in 12th standard? Are you studying in 12th standard? Okay, so like yeah, this like addition of two matrices is associative. So basically I'll be taking three matrices for associative property. Okay, so what is it? A will be equal to Aij, which is M cross N. B will be equal to Bij, which is M cross N. C will be equal to Cij, which is M cross N. Okay, so you are having three matrices. Okay, now I have to add. So basically it will be A plus B the whole plus C is equal to A plus B plus C. Like this will only be the answer. So A plus B plus C is equal to A plus B plus C. This will be my answer. Okay, so this is what is my final answer. Okay, now this is the addition of matrices. Okay, now what is my next one? Third one will be existence of additive identity. So now I'll be talking about existence of additive identity. So basically you'll be taking any matrix. So you take a matrix A and you have to show the additive identity. What does it means? For additive identity, everything will be spoken for only one particular matrix. Okay, additive identity or anything will be spoken for what? One particular matrix. So which is for any matrix A there exists. Okay, there exists a null matrix. So for any matrix A, you will be having a matrix called null matrix. So if you don't know what is null matrix, please go check the previous video. I have clearly explained about all the types of matrices. Okay, so null matrix 0 of same order, that is really important. Same order such that, so you're having null matrix of same order such that A plus 0, A plus null matrix is equal to A, that is equal to 0 plus A. So this will be my answer. Okay, so basically when you add, what is null matrix? You let me again tell you, null matrix is again will be all the elements of null matrix is 0. Okay, so if you're adding some matrix called for example, if you're having a matrix 1 2 3 4, so you're having a matrix 1 2 3 4 and you're adding a null matrix. So whatever element you're adding to 0, you'll be getting the same thing, which is 1 2 3 4. That is what you will be getting. Okay, so I hope you are clear. Okay, so now existence of matrix. So existence of additive inverse. So when you add existence of additive inverse, so basically additive inverse means you're having a matrix. To that, if you add what matrix, you will be getting null matrix. Okay, Mehla, super, super. So that is your null matrix. So basically you will be having what? So for any, and additive is also for a single particular matrix. For any matrix A, there exists a null matrix. So for any matrix A, there exists a null matrix 0 of same order. So you will be having 0 of same order such that, sorry, not null matrix. This is existence of, this is additive inverse. So basically you will be having a matrix. You say the matrix is nothing but A is equal to Aij. And so you will be having, there exists, what will be having? Minus A. Okay, there should be a negative matrix which is minus Aij m cross n such that, so when you're having such that, what will happen? It will be A plus minus A is equal to 0, that is equal to minus A plus A. So this will be my matrix. Okay, this will be my matrix. A plus minus A is equal to 0, that is equal to minus A plus A. So this will be my, so what is my additive inverse is this minus A. The negative A is my additive inverse. Okay, I hope you are clear about what is a additive inverse. Now, properties of scalar multiplication. So basically, before going to the property, let me tell you what is a scalar multiplication of a matrix. So scalar multiplication scalar multiplication of matrix. So when I have it, basically when you listen to the name itself, you'll be able to know. You will be multiplying a scalar to the matrix. So what should I do? You'll be having a scalar k. If you multiply that to a matrix A, so here basically A is nothing but, so if A is equal to Aij m cross n. So if this is your matrix, and then what happens? Then you're multiplying a k to it. So basically k into Aij, that is m cross n. So this will be, when you multiply a scalar outside, each and every element inside the matrix will be multiplied to a scalar. Okay. So example, if you see, when you have A, again you're having 1, 1, 1, 1. I'm just writing an identity matrix to make sure the difference. So when you add 2A, basically 2 is multiplied to each and every element. So 2, 2, 2, 2. Basically 1 into 2. 1 into 2, 1 into 2, and again 1 into 2. So this is my scalar multiplication. Let me copy this and let me do it, then we'll be learning about the properties. Just a minute. Yeah, so this is my scalar multiplication. You have known about the scalar multiplication. Now let's learn about the properties of scalar multiplication. So when I learn about the properties, so basically you'll be having, if A and B are two matrices. So when you're having A and B are two matrices of what order? Of same order. So if you're having two matrices of same order and K and L are scalars. Scalars are basically real numbers. Okay, you can have any real numbers. Basically, it is not even a real number. Even you can have a variable also. Okay, so you can have a variable also. That is also applicable. Okay, that is also applicable. Okay. So, and let me take K and L are any scalars. Okay, so K and L are any scalars. So this will be K plus L is into A is equal to KA plus LA. This will be my scalar. Now what about the next one? So here K into A plus B is equal to K into A plus K into B. Okay, so K into A plus B is K into A plus K into B. Okay, now what about the next one? So K into L into A, basically what is it? So you will be you can basically change the order of multiplication. You can just multiply the L first, then A, then you, or else you can multiply the K first, then L. Okay, so if you're having basically if you're having two scalars, you can not do it in any order. Basically you can divide it in, you can multiply it in any order. And what happens when you multiply 1 into A? So 1 into A is nothing but A only. Okay, same way what happens when you multiply minus 1 into A? So when I multiply minus 1 into A, it is the negative of the number, negative of the matrix. Okay, so this is what is mainly into matrices. Okay, now let's quickly give you a sum. So for example, any sums. Okay, so my example is if A equal to 2432 and if B is equal to minus 2534. If this is that, then find 3A minus B. So I have to find 3A minus B. Here you have scalar multiplication and subtraction. So 3A is basically I have to multiply 3 into 2, 3 into 4, 3 into 3 and 3 into 2. So this will become 6, 12, 9, 6. Like this it will be. Now I have to subtract 3A minus B. So basically it will be 6, 12, 9, 6. So this is what I'll be doing. Now what happens? Minus 2, 5, 3 and 4. Okay, so you have it. How will you do? It will be 6 minus of minus 2, 12 minus 5, 9 minus 3, 6 minus 4. This is what you will be having. So when you have to do, sorry, I think it's not visible. Is it visible now? Okay. So here it will be minus of minus 2 plus 2. So 6 plus 2 is nothing but 8. So this will be 7 and this will be 6 and this will be 2. So this is my final answer. Okay, so I hope you guys are clear with the method and the operations. Basically I haven't gone to the multiplication of matrices. I have just told you about the addition of matrix, subtraction of matrix and its properties basically of addition or subtraction, both the things, addition, subtraction and scalar multiplication. In further classes we'll be learning about more about we'll be learning more about matrices and its properties. So yes, that's all for today's class and I hope you enjoyed the class. So let's meet in another class with a new video. Until then, it's bye from Harismita. Thank you.